What is going on, YouTube? Welcome back to the channel. Today I'll be showing you a powerful technique to help you in doing search problems in your Python code. And this video is especially tailored to beginner or intermediate guys who probably never heard of this method, and that's the Bisect built-in module, which I'll be showing here in a sec. And that has to do with searching sorted arrays. So this is a really common scenario we see on LeetCode HackerRank and a bunch of coding questions where we have to deal with sorted arrays and we have to search a lot of times whether a value exists in the array or whether the most approximate place we'd want to insert that value in the sorted array. So that's kind of what we have with this first brute force method here. So the brute force method of searching through a sorted list and finding if a value exists is actually O of n time. So that's linear time, and that's the brute force method that a lot of beginners do. And I'm sure even a lot of beginners are familiar with binary search, but when they're pressed in a coding interview, they just they blank out. They can't implement the binary search in such a scenario, or they just don't have the time to implement the binary search. So I'm just going to show you a faster method to do that and save you a lot of time in such a scenario. So as you can see with this code here, we have that example sequence. I'm just going to run and show you an example of what it would give me in that case. So I'm just going to pass the sequence. What am I doing here? Find closest brute force. So we just pass it a sequence, and we're searching for 3 in that array. So we want to find the closest index to the value 3, and I'm just going to run it. And I should print that actually, I'm so silly. So print and save. Let's run that. And it's telling me 3 would be an index 2 in this big array. So this sequence is 0 to 10,000 with spaces of 2. Actually, let me go ahead and print that, guys, to show you how that would look, just in case you're confused about that as well. So we're just searching for 3 in this array, and if it doesn't exist, it'll show me essentially like what is the closest index to 3 that I would insert in this sorted array. So this is essentially just like a linear search what I'm doing. But we can actually do binary search in one line of code to save you a lot of time. So we're just going to say from bisect import bisect left, okay? And then we're just going to say the index here is just going to be equal to bisect left. And we just pass the sequence and we pass the goal that we want. So we just do that. And I'm just going to go ahead and save that. And we're just going to return the index actually there. Okay. So it's going to give us the same thing, but it's doing binary search built into Python. So you don't even have to pip install anything. You can use this in your coding interviews very easily. And then you could just go ahead and run that. So if I go ahead and run the same function here, so I'm just going to print find closest binary search. I'm going to pass the sequence, and I'm going to pass 3. And I'll show you that it gives you the same thing. So let me just go ahead and clear this and run it. So you can see it gave me 2 like before there. And let me comment this out, by the way. So it gave me 2 as expected, but this is actually a lot faster. You can't see it yet as to why it's a lot faster. This is actually a logarithmic time, which is significantly faster, especially if you have a huge list or you have multiple lists that you're working with. You're going to want to use this method to do such a search. So I just have this example here where I'm going to show you why it's so much faster. So I just have an example where I have this. I'm calling both functions 1,000 times, and I'm running it with these 2 values, sequence 9,500, just random values I decided to choose. So I'm just going to go ahead and comment this out here and comment that out. And let's just clear this once again. Go ahead and run it. Find index brute force is not defined. That's interesting. Find index brute. Oh, find closest. Oh, I changed the name of the functions. Okay. Let's go do that. Let's copy this here. And then let's go ahead and run this now. So we could see that the speed up for logarithmic time is on the order of hundreds. So you really want to try to use binary search. And thankfully, Python has essentially a built-in binary search that you could use with one line of code just by importing this bisect left. And it'll save you a lot of time when doing search on sorted arrays when you're working with coding interviews, or even in practice. Maybe this has practical purposes. You're working with large data sets, and for some reason you want to use binary search. This can save you a lot of time and a lot of headache by writing less code. So I hope for you new guys, you learned something new, and even you intermediate guys as well. If you did, please like, comment, subscribe. Let me know what you want to see in the comment section below. And as always, guys, thanks for watching. Stay tuned.